What you're looking at right now are our divisibility rules. We're going to use these to help us identify if a number can be divided by one of these numbers. If it can be divided, then these numbers are what's called factors. And you might be wondering, why is 7 and 11 kind of starred out? And that's because they do have rules, but they're overly complicated. And honestly, in order to see if 7 or 11 is a factor, you can always just divide the number by 7 or 11 to see. So that's why I don't really go over how to do them, because there are rules, just like all of these have rules, but they're just a little bit too complicated to be really useful, all right? So anyway, today's lesson, it's not really about the divisibility rules, although we'll use them. It's about the idea of finding factors. And a factor is a number that, and you can see the air quotes there, kind of says go into another number. And I have an example down here for you. Like, for example, thinking about the number 12, 3 times 4 creates 12. And so what we could say is 3 and 4 are factors of 12. But they're not the only factors. You know, we can create 12 different ways. Like, for example, 2 times 6 can also create 12, and 1 times 12 can create 12. And so the number 12 actually has 6 factors. It has the numbers 1, 2, 3. You can see those right here, 1, 2, 3, as well as 4, 6, and the number itself, 12. And that's what we're going to be focusing on today. We're going to be focusing on listing all of the factors of a number. Most of the numbers that we're going to be dealing with are composite numbers, which are numbers that have more than 2 factors. But there are numbers called prime numbers that only have 2 factors. Like, for example, the number 17. The only way to create the number 17 is to multiply 1 times 17. And so you'll notice that prime numbers like 17 have exactly 2 factors. So that's the difference between prime numbers and composite numbers like 12. Now, the way that we're going to be listing factors is called rainbow factorization. Listing factors, or being able to identify factors, is really helpful, specifically when we start getting into fractions, all right? So the way to do rainbow factorization is basically to ask yourself the same question over and over again, and that would be, what numbers go into, which is a code for division, the number that we're looking at, you know? And so I think the best way to kind of do this is with an example. And so the first thing we're going to want to do is we're going to want to identify, is this number a prime number or a composite number? If it is a prime number, then we automatically know that we're going to have 2 factors. That's it, the number 1 and the number itself. If it's a composite number, we're going to have to figure them out. 50 is a composite number. So the way that we do rainbow factorization is we're going to start with the 2 automatic factors. Every number has 2 factors by default, and that's the number 1 as well as the number itself. I mean, think about it. 1 can go into any number, and then the number itself is always going to be its own factor. And so we're going to connect them, and this is kind of what the term rainbow comes from. This connection basically means that these 2 factors multiplied together give us our original number. But we have to keep going. And so we're going to kind of work our way up the numbers trying to identify factors. For example, is 2 a factor of 50? Well, the answer is yes, because 50 is an even number. That's one of our divisibility rules. 2 goes into 50 25 times. So you see how we made another little rainbow connection? Does 3 go into 50? No, it doesn't. If you look at our divisibility rules, you'll see that if we add together the digits of the number, then the original number, it can be divided by 3. Well, 50, you got 5 plus 0. 3 can't go into 5, so 3 cannot go into 50. And another really cool thing is, as soon as we know that a number is not a factor, like right now we know that 3 is not a factor, all of the multiples of 3 will also not be factors. So we automatically know that 6 is not going to go into 50, or 9, or 12, or 15. You get the idea. Can 4 go into 50? No. Can 5 go into 50? Well, yes, 5 can, and it can go in 10 times. Another neat part about doing rainbow factorization is every time that you make a connection like this, any other possible factors have to be in between these 2 numbers. Meaning, if there are more factors of 50, they have to be in between 6 and 9. Well, we already know 6 is not going to be a factor, 7's not, 8's not, 9's not, so we're done. We've listed the factors of 50. It is good to know what your prime numbers are, because if you can identify a number as prime, then you don't have to do this whole rainbow factorization thing. You automatically know the 2 factors are going to be the number 1 and the prime number itself. And so these are the prime numbers from 1 to 100. You'll notice that the number 1 is not a prime number. Technically, it's not a composite number either. The number 1 only has one factor, which is the number 1. And because it only has one factor, it doesn't actually follow the rules to become a prime number. Prime numbers need to have two factors, and that's it. And so if we look at any of these numbers, these are all prime numbers. Like if I had to rainbow factorize, or if I had to list the factors of 61, since I know 61 is prime, it would just be the number 1 and the number itself, 1 and 61. That's it. I don't have to worry about doing other ones. You should try to memorize a few of these. I think the most important ones are kind of like in this kind of area right here. 2, 3, 5, 7, 11, 13, 17. Those are the most common ones. Anything else, it's nice to be able to recognize the number as prime, but you don't have to memorize all of these. Just, 2 through 17. Just know what those numbers are prime. Let's take a look at these three, and we'll kind of list them off really quickly. 58, since it's an even number, is going to be composite. So I'll put the letter C here because it's asking me, is the number prime or composite? Since I want to list it off, I'm going to start by writing 1 and 58 as far apart as I can. And then let's go. Is 2 a factor of 58? Well, yeah, because 58 is prime. Or excuse me, prime. I have prime numbers on my mind. 58 is even, so it's going to be divisible by 2. To check if it's divisible by 3, let's go ahead and add up 8 and 5 together. What we end up getting is 13. So this number is not divisible by 3. It's also not divisible by 4, 5, or 6, or 7, or pretty much any number. So we're done. These are the factors of 58. 13 is a prime number. I don't really need to create a rainbow for 13, but if I did, it would just be these two numbers. 24 is composite. And as a general rule, the prettier the number, like even numbers like 24 or 50 or 64 or something like that, they're going to have the most amount of factors. So if we take a look at 24, you're going to see pretty quickly that we're able to find quite a bit of factors. 2 plus 4 is 6, so 3 is going to go into 24. 24 is also divisible by 4. And now take a look at this. You see how every time I make a rainbow connection, the numbers in between get smaller and smaller and smaller? Well, the only number in between 4 and 6 is 5. We could check to see if 5 is a factor. It's not, but we're done. 5 is a prime number. 93 is composite. Sometimes larger numbers don't have very many factors. It's easy to think, oh, this is a big number. It's going to have a lot of factors, but really it won't. Since it's an odd number, 2 and every other even number will not go into it. 3 will go into it 31 times, but that's it. 6, well, that's an even number, but 9 won't go into it. 11, 7, you could try these numbers, but they won't go into it. And then, so that's it. That's all I wanted to do. I do want to leave you with this one, but you see how we have numbers like 450? Big even numbers like this are going to have a lot of factors. In fact, if I move the hint, there's 18 factors. Now we're going to start with 1 and 450, but think about it. 450 is even, so it's divisible by 2. 4 plus 5 plus 0 is 9, so it's divisible by 3. It's not divisible by 4, but it is divisible by 5 because it ends in a 0. Since 2 and 3 are factors, 6 will be a factor as well. That's in our divisibility rules. We can try 7, but 7 is not a factor. 9 is a factor because 4 plus 5 plus 0 is 9. 10 is a factor because it ends in 0. And now we have to start using our brain a little bit because we don't have divisibility rules for numbers greater than 12. But if we think about it, 15 is going to go into 450, as well as 25, or 18 and 25. And so you can see bigger numbers are going to have a lot more, and it really does kind of look like a rainbow. Okay, there you have it. Rainbow factorization is really important. It helps us figure out all sorts of factors of numbers, and finding factors can be extremely useful, especially with fractions. I hope you enjoyed the video. Thanks for watching Mr. Waller Teach Me Math.